So I've made it sort of nice and pretty here. Here's tagged photos, mobile uploads, uploaded photos, and profile photos. If you look at this row, it has all of the data from one subject. So this person has 0 photos of any kind, right? Whereas let's look at this person. This person has 0 mobile uploads and 0 profile photos, but they have 79 uploaded photos and 37 tagged photos, right? And so for each subject, we could see that there's some variation there, but across the different samples, we also see some variation. So here, down here, I've put step 1. They're all equal. They're not all equal. Alpha equals 0.05. Here's the decision stage. Our K is 4 groups, 4 samples. Our degrees of freedom between is 4 minus 1. We've already done that, but might as well fill this in. Degrees of freedom for subject, the reason why this is there is so that we could find the degrees of freedom residual. Oops. And once we have that, then we could find our critical F. Okay, so degrees of freedom for each subject. We should count how many subjects we actually have here, and we could just count the rows. So I just picked profile photos, minus 1. So we actually have 29 cases, but our degrees of freedom for subject is 28. Now, degrees of freedom residual are those 2 degrees of freedom multiplied to each other. So 3 times 28, and that's going to be 84. And that's our denominator degrees of freedom. So now we could find our critical F. In order to do that, we use F inverse. The probability is 0.05, and our first degrees of freedom is the numerator one, and our second degrees of freedom is the denominator. And our critical F is 2.71. That's our critical F. So once we have that, we can now go on to sort of figure out, okay, from there, let's go on and calculate our samples F. So we'll have to find the samples F statistic, right? Before, I just put it generically because you might have to find T statistic or Z statistic, but in this case, we know because we have an omnibus hypothesis, we need that F statistic, and we have to find the p-value afterwards. So let's find the F statistic. If you go to your example again, this is example 1, as you can see. I've put in all the different things you need. So you need the variance between over the variance, the residual variance. So let's start off with variance between. It's something we already know. We know it's going to split up into sum of squares between and degrees of freedom between. We actually have degrees of freedom between already, so let's just fill that in. In order to find the sum of squares between, we're going to have to find the means for each of these groups. We're also going to need to find out what's the n. The n is actually quite simple because we know that it's 29 for each of these groups. So that makes life a little bit simpler. Now let's find the averages for each of these samples. So for the first sample, I believe this is tagged photos. The mean is 9.93 for, I believe this is mobile uploads. That is 12.45. For uploaded photos, the average is 68. And finally, for profile photos, The average is 1.5. Okay, so now we're going to have to calculate the grand mean. The grand mean is quite easy to do on Excel because you just take all your data points, every single one, make sure not to miss one, and you calculate that average. And the average is 23. And I'm just going to copy and paste that here. What I did was I put a pointer so that it would just point to that top value because the grand mean shouldn't change. The grand mean is always the same. Now that we have all of these values, we could find n times x bar minus the grand mean squared. We could find that for each group. Drag that down. We could find that for each group. And then when we add that up, we end up getting our sum of squares between. And we get this giant number, 82,700, 800-ish. And so I'm just going to put a pointer, equal sign, point to that guy. And then I'm going to find out my variance between. So my variance is still quite large, about 27,600. Okay, so once we have that, now I need to find my residual variance. In order to find residual variance, I know I'm going to need to find all this other stuff that I didn't necessarily plan on. So one of the things I do need to find is my SS total as well as my SS subject. I'm going to start with SS total because although the idea is simple, doing it on Excel, it looks a little crazy just because it takes up a lot of space. Because we're going to need to find the squared distance away from the grand mean for every single data point. Every single data point, right? So here are all my data points right here. All my data points. Now I'm going to need to find the squared distance of this guy away from the grand mean, this guy away from the grand mean, this guy away from the grand mean, this guy, this guy, this guy, this guy. All of these guys away from the grand mean, and then add them all up. What's helpful in Excel is to create separate rows and then to sort of add them up sort of at the end, right? And so I'm just going to save these for later. And so this is, I've already put in the formulas here. This one says tagged, just for the tagged photos. It's sort of my partial way to find SS total, just for the tagged photos. Then I'm going to do it for the mobile photos, then for the uploaded photos, then for profile photos, and then add them all together. So these are sort of like subtotals. So what I need to find is that data point minus the grand mean. And I'll just use this grand mean that I found down here. But what I need to do is I need to lock that down. I need to say, always use this grand mean. Don't use any other ones. I'm going to put that in parentheses so that I could square it. Okay. So here, I'm going to do that all the way down for tagged photos. And I'm going to just take this across for mobile, uploaded, and profile photos. And that's the nice thing about Excel. It will give you all of these values very, very easily. I'm just going to shorten this for a second just to show you what each of these is talking about. So if I click on this one, this cell gives me this value minus my grand mean, which is locked down, squared. Right? So I have now every single data point's squared distance away from the grand mean, and these are all the differences, squared distances. Now, I need to add them all up. So I'll put sum here. And I'm not just going to add up this column, I'm literally going to add all of these up. And so our total sum of squares is 257,000. So I'm going to go down to my sum of squares total and just put a pointer here and say, that's it. Okay, so how do I find my my sum of squares for the subject level variation? Well, this I know I need to find the mean for every subject. Then I need to find the distance between that mean and the grand mean, square that, and multiply it by how many groups I have. The nice thing is the number of groups I have is constant. It's always 4 for everybody. So let's go ahead and find subject level means. So subject means are going to be found by averaging one person's measures for all 4 samples, right? And so that guy's average is 0. I can just copy and paste that down. And if I wanted to check, this one takes the average of these 4 measures. So this is the subject level variation. And this shows you that this guy has a lot fewer photos, period, than this guy. He has just on average a lot higher photos than this guy. And this guy is sort of in the middle of those two, right? Once we have these subject level means, now we could find this idea, k times the difference squared for each subject. So I know my k is going to be 4 times my subject level mean minus the grand mean, and I'll just use my already calculated grand mean down here. And I need to lock that grand mean down because that grand mean is never going to change. Squared. So I can take that all the way down, right? Once I have that, then I probably want to add them all up in order to get my sum of squares for within subject variation. I always put this little sum sign so that I know that this isn't another like data point. It's a totally different thing, sum. And once I have that, it's 56,600. I now know my sum of squares within subject. Okay, once I know all those things, now I can finally calculate sum of squares residual because I have all my ingredients. I have my sum of squares total minus the sum of squares per subject plus the sum of squares between. And I could obviously distribute out that negative sign, but I'll just use the parentheses. Okay, so here's my leftover sum of squares. That's whatever's left over, unaccounted for. And I've already figured out my DF residual. And so here, I'm going to put my sum of squares residual divided by my degrees of freedom residual. And there I get 1,400. So now we can finally calculate our F by taking the variance between and dividing that by the variance, residual variance. And there I get 19.69, which is quite a bit above the critical F of 2.7. Now, once I have that, now I could find my p-value. So to find my p-value, I would put in my F dist, put in my F value, my numerator degrees of freedom, as well as my denominator degrees of freedom. And I get 9.3 times 10 to the negative 10 power. So that means there's a lot of decimal places before you get to that 9. So it's very, 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 very small p-value. So what do? We reject the null. Great. Also, remember that in a F-test, all we do is reject the omnibus null hypothesis. That doesn't mean we know which groups are actually different from each other. So when you do reject the null after doing an F-test, you do want to follow up and do post hoc tests. There's lots of different post-hoc tests. You might learn Tukey's post-hoc or Bonferroni corrections. So those all help us know the pairwise comparisons to figure out which means are actually different from which other means. And you probably also want to find effect size. And in an F-test, effect size is not D or G. Instead, it's eta squared. Oops. Eta squared. All right. So we would reject the null.